Welcome to qnawire.
So, in this question, actually, this is symmetry. That means the part left to the FG and right to the FG is symmetry. In this question, we need to find only the part left to the FG. So here in point A, there is a pin support. So because of this type of support, the support is this type. There will be one vertical force. Let's name it as R A Y, and there will be another horizontal force also. Let's name it as RAS, and let's draw the forces. This is vertical, this is horizontal. RAY, RAX. Now, from equilibrium of the truss, the support reaction in its direction at joint A is 0. So, at joint C, so the equilibrium of truss, the support reaction in its direction. Reaction in its direction, that is the RAX equal to 0. So now at joint C, summation along y equal to 0 gives you, therefore f bc equal to 0, that is at joint C the fbc will be equal to 0 because fac is collinear to fce, so fbc is a zero force member, so that is equal to 0. And at joint J, the summation along x equal to 0 gives you f I j equal to 0, that is fij is equal to 0. That means here this is a at point j, right? Yeah, at point j you can see hj is collinear to jl, so the fij will be 0 force member, so that is 0. And summation along y gives you f j k also will be equal to 0, like fjk is also equal to 0 because fj fhj is collinear to fjl. That's why fjk equal to is a 0 force member, that is equal to 0. Joints having two collinear members, the third member will be a 0 force member if no external commands act along this member. And at joint I, at joint I, The summation along y equal to 0 gives you f of h I equal to 0. That is at joint I, f of hi, that is gi and ik is collinear, so fhi equal to 0. That is the joints having two collinear, that is two collinear gi and ik. The third member hi will be a zero force member if no external components at along the member. We already found ji is 0, so hi should be definitely will be 0. So these are the zero force members, and let's go to the next one. Here in point E, there is a pin support, and due to this kind of support, because the support is this type, there will be two reactions. There will be one vertical, let's call it as EY, as well as one horizontal reaction. Let's call the horizontal reaction as EX. And in point F, there will be one roller support. There is one roller support, and because of this kind of support, there will be one vertical reaction. Sorry. Vertical reaction, let's call it as F1. Now let's draw the reactions here in the figure itself. This will be Fy, this will be Ey, and this will be Ex. Now from equilibrium of the truss, the support reaction in X direction at joint E is 0. That is from equilibrium of the truss. The support reaction at joint E along X direction, that is EH, will be 0. You will get EH is 0 because that is the only reaction along X direction, so definitely it will be 0. And at joint B, summation along X equal to 0 gives you F BF equal to 0, and summation along Y equal to 0 gives you FBG equal to 0. That is at joint B, FBF and FBG will be equal to 0, as AB and BC is collinear. So when we consider the first one, AB and BC is collinear, so FBF equal to 0. Then when we consider along Y direction, AB and BC is definitely collinear, so FBG equal to 0. So these joints having two collinear members, that is in case of FBF, this is collinear, AB and BC is collinear, So there are two collinear members. The third member, this one, will be zero force member if no external components are along this member. And in case of FBG, FG and FGH is collinear, so this will be the third member, that is, say, zero force member. Now let's move to the next joint. At joint C, summation along H equal to 0 gives you FCG equal to 0, and summation along Y equal to 0 gives you FCH equal to 0. So just joints having two collinear members, a third member will be a zero force member if no external components settle on this member. So these are the zero force members. So FBF, FBG, FCG, FCH, and the first truss FBC, FIJ, FJK, and FIH is zero force member. I hope you understood the problem. Thank you.